Welcome back to it. It's Maths Master Class with Leo. Welcoming back all the grade 12s. Welcome back to our winter classes. Today we are doing our November question paper, which is 2018. Our focus area is on number pattern and series. And we are starting with question 2. Our question 2 is as follows. Starting with 2.1.1, we're given the series 2, 3, 10, and 23. That is our series. They're saying, given the quadratic sequence, okay, write down the next term of the sequence. That is 1 mark. They want to know what is the next term of the sequence. We're given that this sequence is a what? Is a quadratic sequence. So we will say 3 minus 2, it gives us 1. 10 minus 3, it's 7. And then 23 minus 10 is what? 23 minus 10 is 13. And then lastly, we'll say 7 minus 1 is 6. 13 minus 7 is 6. So the next one, 19 minus 13 is 6. Right? So when I say 23 plus 19, I'm going to get my next term. So let's get our calculator. I say 23 plus 19, I'm getting 42. 42, it is my next term in this case. Therefore, the next term is equals to 42. This is question 2.1.1. Right? Now, question 2.1.2. Determine the nth term of the sequence. They want to know your general equation or your general term, your formula. So in this case, we know that this is a quadratic. It must be in this format. Tn is equal to an squared plus bn plus c. Right? So when calculating the value of a, we know that 2a is equal to our d1. So in this case, not d1 but d2, the second common difference. Second common difference, right? So in this case, 2a is equals to 6. Divide by 2, divide by 2. Value of a is represented by 3, right? Then after that, 3a plus b is equals to this d1. So in this case, we will say 3 into 3 plus 1 plus b, which is equals to 1. Which this is equals to 1, which is that one, right? And then b is equals to 1 minus 9, b is equals to negative 8. And then a plus b plus c is equals to term number 1. And then a is represented by what? By 3 minus 8 plus c. This is equals to 2. And then if I take this 2 to the other side, I'm going to have c is equals to 2 plus 5, which is 7. C is equals to 7. And then my general term, it is Tn is equals to 3n squared minus 8b, or minus 8n plus 7. That is my Tn. Then the next question, which is 2.1.3, they want to know the 20th term. So we'll say Tn is equals to 3n squared minus 8n plus 7. This is T20 is equals to 3 into 20 squared minus 8 into 20 plus 7. And then punch your calculator, what do you get? See, you have 3 into 20 squared minus 8 into 20 plus 7. 1074 is my solution for this question. So my solution is 1047, not 74 but 47. 10, 47, 1004, 7. Okay, the next question, which is a 2.2, we're given an arithmetic sequence which is 35, 28, and 21. Calculate which term of the sequence will have the value minus 140. So the first thing that we need to get here, it is the general term. So Tn is equals to a plus into n minus 1 close bracket d, right? D is equals to T2 minus T1, where T2 is 28 minus 35. This gives me minus 7, right? And then Tn is equals to A is 35 plus into n minus 1 close bracket d, which is negative 7. And then here I'm going to have 35 minus 7n plus 7, and then this gives me negative 7n plus 42. See, 35 plus, okay, yes, plus 42. And then I'm told that they want me to calculate the term which will have the value minus 140, meaning I need to calculate the value of n. So here I'll have negative 140 is equals to my negative 7n plus 42, and then negative 140 negative 42, this is equals to negative 7n, and then negative 182 is equals to negative 7n, divide negative 7, divide negative 7, therefore n is equals to, let's see, what are we getting on our calculator? Okay, 182 divide 7, this gives me 26. So my solution will be a positive 26, because negative divided by negative, it will be positive, right? And then let's go to the next question, 2.3. Let me go to the next page, 2.3. For which values of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? Okay, let's start with the sum of the first nth terms of the arithmetic sequence. Sn is equals to n over 2 into 2a plus into n minus 1 close bracket d, right? And then we don't know what is the value of n, we substitute it as it is, divide by 2 into 2. We know what is the first term of the arithmetic sequence. Believe it was 35, yes, here 35 plus into n minus 1 close bracket, the difference we got negative 7 close bracket, and then this is n over 2 into 2 multiplied 35 is 70 minus 7n plus 7, and then we have n over 2 into negative 7n plus 77, right? This will be negative 7n squared over 2 plus 77n over 2, right? And then they're saying, for which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in 2.1? So in this case, they're saying, for which values of n will Sn be equals to Tn, right? So Sn, it is negative 7n squared over 2 plus 7n over 2. But this Tn is for the quadratic, right? Not for the for your arithmetic, but for your quadratic, which is equals to, we got it as 3n squared minus 8n plus 7. This was the Tn. This was the general term for our quadratic sequence. And then rearranging, I'll have 3n squared. Taking this to the other side will be plus 7n squared over 2. And then I have negative 8n, negative 77, n over 2 plus 7. This is equals to 0. And then I have, let's see, what is 3? 3 plus 7 over 2. That is 13 over 2. And then 8, or negative 8, negative 77 over 2. Let's see, what is the solution? 93, which is negative 93. So I'm going to have 13 over 2 n squared minus 93 n over 2 plus 7. This is equals to 0. And then if I want to remove this fraction, I'm going to cross multiply by 2 over 1. Even this side 2 over 1. And then I have 13n squared minus 93n plus 7. This is equals to 0. Not 7 but 14. Because it's going to be 7 times 2. And then you can either use your quadratic equation to solve that. I'm going to use a calculator to save time. We'll set up equation 3. And then I have 13 equals to negative 93 equals to 14. And then I'm going to have, okay, the first one is, let's see, 7, the second one is 2 over 3. So n will be, let's see, n will be, let me just remove that, n is equals to 7, or n is equals to 2 over 13, where n cannot be 2 over 13. Therefore, the value of n is equals to 7. Right? The value of n in this case is equals to 7. Let's go to question 3. I hope you understand. If you have a problem, just go through our notes in our first introduction videos. You'll get to understand these things better. Let's go to question 3. Question 3 is one of the easiest, actually, because we almost given everything. So question 3, they're telling us a geometric series is a constant ratio of 1 over 3. Constant ratio 1 over 3. So for 3.1, we already know r is equal to 1 over 3. And they're saying sum of infinity is equal to 6. Calculate the first term of the series. So they want to know what is the value of a. So sum of infinity is equal to a over 1 minus r. And then sum of infinity is equal to 6. Then this is a over 1 minus into 1 over 2. This is 6 is equal to a over 1 over 2. When I cross multiply, 6 multiply 1 over 2 is equal to a. Therefore, the value of a is equal to 3. The value of a in this question is equal to 3. Let's go to 3.2. Calculate the 8th term of the series. So for us to calculate the 8th term, we need to know what is the Tn. So Tn is equal to AR to the power n minus 1. And then Tn is equal to A is represented by 3 into R is 1 over 2. And then n minus 1. Right? And then T8 is equal to 3 into 1 over 2 to the power 8 minus 1. And then our solution will be, let's see, remove u. 3 into 1 over 2 to the power 7. 3 over 128. That is our solution for 3.2. Let's move to 3.3. 3.3, let's see. 3.3, we're given some of the terms. That is this. Okay, some of the terms. This is n on top, and then k is equals to 1. 3 into 2 to the power 1 minus k. They're saying this is equals to 5.8125. Right? They want us to calculate the value of that guy, the value of n. The value of n. What did I do? Okay. They want us to calculate the value of n. So for us to calculate the value of n, we need to know the series. This series, let's try to identify this series. So 3 into 2 to the power 1 minus 1 is to 3 into 2 to the power 1 minus 2 is to 3 into 2 to the power 1 minus 3. Last one, 3 into 2 to the power 1 minus 4. And then for this one, definitely can see this will be 0, this will be 2, this will be 3, because 0 to the power 2 to the power 0 is 1. Then let's get the next one. Calculator. Let's see. So inside here we have 2 to the power 1 minus 1. Let's prove that one. It's 3. 1 minus 2. 3 over 2. 1 minus 3. 3 over 4. 1 minus 4. 3 over 8. Okay, so here we have 3 over 2. 3 over 4. And let's see. Am I doing the right thing? Yes. 3 over 8. 3 over 8. Right? Okay. Now, we need to calculate what? We need to calculate the value of r in this case, because remember, when we're dealing with this type of equation, we're looking for the value of n. So Sn is equals to Na into r to the power n minus 1, close bracket, divided by r minus 1. We already know what is the value of a. We need to know what is the value of r. We also know the value of Sn. Sn is given as 5.8125. We need to know the value of r so that we can calculate the value of n. So r is equals to T2 over T1, which is 3 over 2 divided by 3. And this will give us 1 over 2. Let's just prove it. 1 over 2. This is 3 over 2 divided by 3. Definitely 1 over 2. And then from there we substitute. We know what is this. So we have 5.8125. This is equals to what? This is equals to a is 3 into 1 over 2 to the power n minus 1, close bracket, divided by 1 over 2 minus 1. Therefore, this will be 5.8125 multiplied by negative 0.5 is equals to 3 into 1 over 2 to the power n minus 1 divided by 3 divided by 3. This and that, they cancel. Let's see what are we getting. Okay, I have 5.8125 multiplied by negative 0.5. Solution, answer divided by 3. This is negative 31 over 32. Negative 31 over 32 is equals to into 1 over 2 to the power n minus 1. Take this to the other side. This will be minus that. Then plus 1. This is equals to 1 over 2 to the power n. Let's get our calculator. let's say our answer plus 1, we're getting 1 over 32. 1 over 32 is equals to 1 over 2 to the power n. This is like 2 to the power negative 5 is equals to 2 to the power negative n. Therefore, n is equals to 5. Right? The solution of that, n is equals to 5. Let's see the next question, which is the last one. Okay, what's happening? Let's see. Okay, fine. Let me just input that picture again. Let me input the picture again. Where is it? There. Okay. Okay, where is that picture now? Fine, let me just erase this and do the last question. Let me erase this part and do the last question. Hope so far you understand how to deal with these questions and how to manipulate them. Don't forget, basics are very, very important. If you understand basics, then it will be easy for you to understand anything. If you understand better the basics of a certain topic, then it's easy for you to go around solving questions, right? But if you are struggling with basics, there are high chances that you will struggle with even easy questions. Okay, now let's check this one. You are given if, they're saying if sum of ends at 20. Let me try to do that. Yeah, ends at 20 and then starts at k is equals to 1. Then you have 3 into 2 to the power 1 minus k. They're saying this is equals to p. If that is equals to p, meaning Sn or S20 for this, S20 for this is equals to p, right? And then they're saying write down this one, which ends at 20 as well, starts at 1, and then you have 24 into 2 to the power negative k. You must write the sum of this in terms of p, right? So let's start. The first thing that you need to do here is to get the Sn. But let's start with the series. A series here we have 3 into 2. Oh, this one we did it. We did this a series similar to this one. Not sure if I erased it. Let me see. Definitely I did. But I'm gonna write it down again. I remember it. It was 3 over 2. Our series was 3 is to 3 over 2 is to 3 over 4 is to 3 over 8. This series represents this one, right? So for this, let's calculate S20. So S20 will be equals to A is represented by 3 into 1 over 2 to the power 20 minus 1. Then R for this, it is, let me see, it was 1 over 2. 1 over 2 minus 1, right? And then they're saying this is equals to P, remember? And then in this case, what will I get? Let me punch my calculator. I have 3 into 1 over 2 close bracket to the power 20 minus 1 close bracket, then 1 over 2 minus 1. This is approximately 6. So 6 is equals to my P, right? So my S20 is equals to 6, which is equals to P, right? And then let's get for this one, 24 into 2 to the power negative 1 is to 24 into 2 to the power negative 2, and then 24 into 2 to the power negative 3. Let's see my calculator. 24 into 2 to the power negative 1, it's 12. Then negative 2 is 6. Then negative 3 is 3. So 12, 6, and 3. 12 is the 6, is the 3. Right? And then R is equals to 6 over 12, which means R is equals to 1 over 2 as well. And then let's get our S20. S20 is equals to first value is 12 into 1 over 2 to the power n, which is 20 minus 1, and then 1 over 2 minus 1. What is our S20? Let's see our calculator. 12 into 1 over 2 to the power 20 minus 1, then 1 over 2 minus 1. This is 24, right? And then S20 is equals to S20. S20 is equals to S20. Erase here. Erase. S20 is equals to S20. Substitute now, right? And then this S20 is 24, which is equals to this S20 is what? Remember, I can split this 24 into 4 times 6, right? Why am I doing that? Because I know this is 20. This one is equals to P, which is equals to 6, right? Instead of having 6 here, I can say my solution will be 4. Instead of 6, I can substitute P. Because P and 6 are equal, then I have my solution as 4P. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango means thank you. Tango!